There we go. So today we are talking about the complex number system. So if I can get this thing to work, we will be writing down the complex number system. Complex number system makes it seem like it would be difficult to deal with, but really it's not that bad. Once you learn the rules of it, it's not that bad. And the main thing you need to remember is in complex numbers, we're talking about A plus or minus BI, where I is imaginary and A is real, right? So this would be a real number, and this would be an imaginary component, right? The key thing to remember when we're talking about the complex number system is that I squared equals -1, right? The other thing to remember is the square root of -1 equals I. Those are the two biggest pieces of information that I have to offer you when we're talking about the complex number system. Because knowing these things allows us to get rid of the imaginary component when we need to. And the whole idea of this is we had the square root of, say, any negative number. Say I have the square root of -4. And we can look at that all we want, and we know that nothing times itself will equal -4, right? Because if I have -2 times -2, that's going to equal +4. When we're talking about square roots, we're saying something times itself equals that, right? And so the way I say mathematicians, the way mathematicians decided to deal with that was to pull the negative out as an imaginary number, as an I, right? So I could rewrite this as I times the square root of 4, and then we know that the square root of 4 is just plus or minus 2, so it would be plus or minus 2I, right? And that all that I means is the square root of -1, right? And that's something you're going to want to remember, especially when we get into, excuse me, multiplying these things. So what we're going to talk about today is we're going to talk about operations on complex numbers. So basically adding and subtracting complex numbers. And I'm just going to give you a couple examples. They are not that hard. Adding complex numbers is really, really easy. Subtracting them, still pretty easy. It just requires so we're going to do operations. Operations are addition, subtraction, multiplication, and division. We will not be talking about division today. We're only going to go through addition, subtraction. So when we're adding complex numbers, we want to talk about, well, I have problems written down, but I'm too far away from them to see them, and then I get too close to see them. So when I have, for generic, A plus BI plus C plus DI, we would wind up with A plus C plus B plus DI. Now all that did is factor it out. What does that mean in terms of real number examples? It just means that we add them. We add our like terms, right? Just like we've done over and over again with anything else when we're talking about variables. So if I have 4 plus 7i plus 1 minus 6i, right? The first thing I know, because we're dealing with addition, the parentheses don't really mean anything. We could go ahead and pull everything out of the parentheses if we want, right? And then we can just combine our like terms. 4 plus 1, well, that's 5. 7i minus 6i, well, that just leaves me with I. So I have 5 plus I. Keep in mind that this is the order that we write our complex number. We always have our real component first, then plus or minus our imaginary component, right? That's it. And if you enter that differently, whether it be in WebAssign or in Delta Math, if you write I plus 5, you will probably get it wrong. And then you'll have to go and look and go, well, what happened? What happened to all of that? And it's usually just you put it in the wrong order and they're not going to recognize it in that order. So notice in here, I had a subtraction component, but I wasn't subtracting these two pieces from each other. When I do subtraction, or subtraction, right? Here we have sum. Sometimes you'll say, what is the sum? When we're adding, it's sum. When we're subtracting, it's a difference, right? So what if I have, let me find one with a difference in it. What if I have 3i minus, negative 2 plus 3i minus 2 plus 5i. What happens when we're dealing with a difference is we have to distribute these negatives into the parentheses, right? Because we're not just subtracting this first number, we're subtracting the entire piece, right? So if I'm going to rewrite this, that got big. It got big to 147% or something like that. Maybe a little bigger now. So when I rewrite this, I'm going to write it as equals. Well, our 3i isn't going to change just yet, right? But I have to distribute this negative into each piece, and it's just going to change the sign on each piece. So negative times negative 2 equals plus 2. Here it's going to be minus 3i. Now we have another negative here, and we're going to have to distribute it into each piece of this. So negative 1 times 2 is negative 2. Negative 1 times 5 is going to be negative 5i. And now we are able to pull it all out of the parentheses, and we can combine our like terms. Remember, we want real numbers first, so we want to deal with our non-I values first. So what do I have in non-I values? I have 2 and negative 2. So 2 minus 2 is just 0. So now I have 3i minus 3i. Well, that's 0. Minus 5i gives me negative 5i is what that whole piece comes to. And we can mix these up a little bit too, right? There's nothing that says we can't have our addition and subtraction together. So say I have 3 plus 2i plus 4 minus I minus 7 plus I. We're going to do the same thing, right? We're going to look at these. Well, here, no negative, nothing on the outside. I can just rewrite this, 3 plus 2i. Same right here. On the outside here, I have a positive. So this can just come right out of the parentheses. And I would have plus 4 minus I. But here, I would have to distribute. So that becomes minus 7, and that becomes minus I. And now we can go ahead and combine our like terms. Real numbers first. So if 3 plus 4 is 7, minus 7, bam, we're at 0 again, which is super convenient. So right now I have 0. I have 2i minus I. Well, that's just I. Minus another I. That gives me minus 0i. So the whole thing is just 0. So play with these a little. You're going to have some opportunities to work on them in Delta Math. The last thing we want to talk about is multiplying complex numbers, because then we have to deal with what we were talking about earlier, which is that I times I squared equals negative 1, right? So that's one thing we need to remember. I times I equals I squared, which equals negative 1, right? Very important part when we're talking about complex numbers. So if I have, for example, say 4 times negative 2 plus 3i. We would multiply this just like we would multiply anything else when we're dealing with binomials. We're going to distribute, right? So we would go 4 times negative 2 gives me negative 8. And then 4 times 3i just gives me plus 12i. And in this case, we're just going to treat the I like any variable, right? If we only have one of them, it just stays I, just like any other variable. But every time I touch the screen, I make it bigger. But let's look at another example. Say I have 2 minus I times 4 plus 3i. So we're multiplying. Ooh, that just wanted to go with me. Oh, what the heck that was all about. So when we multiply any binomial in algebra, we have to distribute, right? We're going to take this piece and we're going to multiply it times this one. 2 times 4 gives me 8. And then we're going to take that same 2 and multiply it times this piece. 2 times 3i gives me plus 6i. And then we're going to do the same thing right here, right? We're going to go minus I times 4 gives me minus 4i. And here I'm going to go minus I times 3i gives me negative 3i squared. All right. And this is where things get a little bit different. I can't combine my I squareds with my i's, but we can make this right now a little bit smaller. 8 plus 6i minus 4i is 2i. Oops, sorry. That's a minus, not a plus. Right there. Minus 3i squared. But what did we say that I squared equals? Does anyone remember? -1. So right here where I have my I squared, I'm going to plug in -1, which is going to give me 8 plus 2i. -3 times -1 is just plus 3. And so now I can combine these like terms and I get 11 plus 2i. Right? That's my final answer. I can't compress that anymore. Right? And that's what it's going to be like when we're dealing with complex numbers, right? You're going to, anytime you see that I squared, you're going to change it into a -1. When you get used to it, what you'll see is all it ever does when you have that is change the sign of what's out in front, right? Because multiplying anything times -1 just changes the sign. So anytime you see that I squared, the I is going to go away, right? This would go away, and this would become a plus, if that makes any sense at all. So you're going to get ample opportunity to play with these. We'll do one more quick example because why not? I'm feeling chatty. So if I have 3 plus 2i squared, right? That's really saying 3 plus 2i times 3 plus 2i, right? And we can do the same process with that, right? We've got our 3 times 3 equals 9. 3 times 2i equals plus 6i. Then we've got 2i times 3i, that's plus another 6i. 2i times 2i gives me plus 4i squared. So if I look at this now, I have 9 plus 12i, right? We add those two together, plus 4i squared. Well, that's just 4 times -1, which gives me 9 plus 12i minus 4. And then we can combine our 9 and our 4, right? 9 minus 4 is 5 plus 12i. So we're not dealing with anything super complicated here today. It's nothing you haven't seen before. I know you go over complex numbers in every Algebra 2 class, so even if you didn't have me for Algebra 2, I know you've played in complex numbers a little bit. And all I've given you is I've given you 5 mixed addition and subtraction problems and 5 multiplication problems on Delta Math. You should be able to whip right through it. You don't even have to show me your work. It's easy points on Delta Math for you. Any questions? I think I'm going to stop recording now because I'm just so sick of looking at me on the screen.